Hello again, Honors Probability and Stats. This is chapter 7.3, dealing with areas under any normal curve. What are we going to focus on today? We're going to compute the probability of standardized events. We're going to find a z-score from a given normal probability and also the inverse. And we're going to use the inverse normal to solve guarantee problems. All right, again, it's just another step from 7.1 to 7.2 to 7.3. Okay, so 7.3 is just going to add a couple more little things in terms of what's given to you. And then the harder problems are where I give you the percentage and you have to find the z-score. So you're kind of going to go backwards in the chart. So here we go. Just a reminder, this is the formula that we're going to be using. We used it in 7.2 as well, but it's going to be more prevalent in 7.3 to find a z-score. So in this first example, let x have a normal distribution with a mean of 10 and a standard deviation of 2. We want you to find the probability that an x value selected at random from this distribution is between 11 and 14. So the probability that my value of x is in between 11 and 14. Okay. So what we need to do is we need to turn this in the probability of being in between a z. So we must convert both the 11 and the 14. So the formula, z is equal to raw score, take away the mean, divided by standard deviation. So that's 1 divided by 2, or 0.5. So this is 0.5. And then the z-score of the 14, which is 14 minus 10. Make that a little bit better. Minus 10 divided by 2. So that's 4 divided by 2, or 2, or I like 2.0. Makes it easier on the chart. So if you think about the last example I did on the 7.2 video, I did an in-between. It's the one where we look up this z-score percentage, which is the larger, and subtract this z-score percentage, which is the smaller. There's the work that was just done, just so you guys know. There's the smaller z, there's the larger z. We look at the area under the curve for each of them. And then to find it, we're going to look up the 2.0 on our chart, and it yields a 0.9772. We look up the 0.5 on our chart, it yields a 0.6915, and we must subtract them. Final answer, 0.2857. Remember, in between is largest percentage minus the smallest percentage is what gives you the in-between area. So in a sense, 7.2 already gave you those z-scores. 7.3, I give you the raw value, you turn them into z-scores, and then do the same work. That's the difference between 7.2 and 7.3. And now to use the inverse. Okay. So this example says, Magic Video Games Incorporated sells an expensive video game package. Because the package is so expensive, the company wants to advertise an impressive guarantee for the life expectancy of its computer control system. The guarantee will refund the full purchase price if the computer fails during the guaranteed period. The research department has done tests and shows that the mean value or the mean life is 30 months for that computer system, with a standard deviation of 4 months. So they gave us the mu, they gave us the sigma. The question is, the computer life is normally distributed. How long can the guarantee period be if the management does not want to refund the purchase price on more than 7% of the Magic Video packages? So notice this one does not give us our z-score or a raw value. It gives us 7%. Well, if you think about it, I want the 7% to be here. Well, not I want, it needs to be. Because think about it. If you own that company, if 7%, which is this little small percentage, goes back, you'll stay in business. But if this many are returned, 93%, no, you're not going to be in business very long, okay? So that's where our 7% falls. So that means we're going to be looking for this z-score that relates to 7%. Normally, I gave you that z-score and you looked up in the body of the chart and found that percentage. A little bit different. This is why they're inverse. So this is what I just kind of explained to you. This is what we're looking for, and this is the value that we are looking for. So instead of looking up a z-score, you're going to look within the body of the chart. You're going to find the value that is the closest to 7%, which is 0.0700. Well, when you start looking, you get to a 0694 and an 0708. This one is 0.0008 away from the 07, and this guy is 0006. I don't care if it's above or below. I want the one that is the closest. This is not closer. This one is closest. Then you go this way and get that number, and you go this way and get that number, and you see it's a negative 1.48. That is a z-score that relates to 7%. And now once you have the z-score, we can set up our formula. Now I'm going to manipulate this formula real quick just so you can see. Z is equal to x minus mu divided by sigma. Well, if I multiply both sides by sigma, I get sigma z is equal to x minus mu. And then I'm going to add mu to both sides, and I get mu plus sigma times z is equal to x. Therefore, we have a new formula, mu plus sigma z. So if you're trying to find x, we can use this formula right here. And that's where this came in. Here's our mu, here's our sigma, here's our z. Okay, so 30 months was given to us early, 4 months was the standard deviation, and you just found that z-score. This is what comes out of the calculator. Therefore, 24 months we want to round normally. Okay, the company can guarantee the Magic Video package for 24 months. And if it does last for 24 months, they're going to have less than 7% that come back. So that's the end of 7.3. So in a sense with 7.3, we're going to have to use this formula here to find a z-score. And we're going to have to use this formula here if you are given a percentage which finds a z-score, and you have to find the raw data. But all the work is still the same, just like 7.3. And then the worst, or just like 7.2, sorry about that. And then the worst one is looking up a z-score when I give you a percentage. You have to look in the body of our chart and find out our values. All right, that's 7.3.